Students, we are going to study about data structure or data handling in Java. Okay, so this is a very important chapter in class 12th also, because now the reduced syllabus also they added the data structure. Okay, so data structure means structure is a concept of creating logical structures in the memory in such a way that by using small space of primary memory, numerous data items should be stored. Such structures are called data structure. For example, arrays, stack, queue, linked list, tree, graph, etc. Okay. So first of all, we are going to see what is simple data structure. You have come across arrays. So we studied about arrays. uh, So we studied about arrays, that is single dimensional array as well as multi-dimensional array, the previous chapter. So the arrays means we are able to store large amount of data type, datas with a similar data type. Okay, so data structure is a concept of creating logical structures in the memory in such a way that by using small space of the primary memory, numerous data items could be stored. Such structures are called arrays, stack, queue, linked list, tree, graph, etc. So first of all, we are going to see what is called as a stack. So stack is a memory structure which is similar to single dimensional array, but it is used with certain restrictions which are as follows. Okay, so in stack, whatever we are putting inside in the queue or the stack, that should be putting in the large should be replaced first. Okay, so there is only one entry to put the data items, as well as on the same entry we are able to take out the data. So it is a last in first out nature. So stack is a memory structure which is similar to single dimensional array, but it used with certain restrictions which are as follows. Only one end is open for entry and exit of the data. Second one is no element can be accessed from any middle cell. Okay, we cannot able to take it from the middle. So it works on last in first out nature. So in the figure you are able to see a stack. So this is a tub that is filled with some bricks or whatever it may be. So there are 4 bricks are there. The first bricks is in the end of the tub. Okay, so the last brick now occupies the first space. So whatever we put it inside at the last will taken in the first. Okay, so the stack is a last in first out technique. So the stack contains a stack pointer which points the topmost element of the stack. The following operations can be performed with the stack. Okay, so whatever we put in the last, that will occupy the space in the first. So if we are inserting something inside the stack pointer will increase its value one by one. Okay, the next one is push operation. It is a process to enter an element in the stack. To do so, increase the stack pointer by 1 and then store the defined element in the position denoted by the stack pointer. If the stack pointer equal to n means that is the size of the stack. So when the stack pointer reaches to n, uh, we cannot able to insert another one element inside the stack. So it means even the stack pointer reaches to n means the stack is overflow. That is, it occupies its capacity. We cannot able to insert anymore. Then pop. Pop means we are able to take one by one. Okay, this process can be used to retrieve an element from the stack. First of all, take out the element from the stack and then decrease the stack pointer by 1. If the stack pointer is null, stack pointer is 0 means there is no elements inside the stack. That means the stack is underflow. So this is the algorithm for the push operation. Push operation means first we have to check whether the stack is overflow or not. That is stack pointer equal to size of the stack. If it is the size of the stack, then we have to write that the stack overflows. Okay, if it is not like that, we are able to insert the elements one by one, and the stack pointer will increase the value by 1. So first check for overflow. If the SP equal to size means n. Okay, display stack overflows and return. So if the stack is overflows, we cannot able to push any elements inside it. Okay, so second one, increase the stack pointer by 1. SP equal to SP plus 1. Then push the elements. If the stack pointer equal to item, then return. So if there is a space, every time the stack pointer will increase its value by 1 and it will push the element. Okay. The next one is pop operation. Pop operation means we are taking out the element. Okay. So stack is a stack of capacity. So if you want to take out element from the stack, first you have to check whether the stack is underflow or not. Okay, so if it underflows, then we are not able to, if it is underflows, we are not able to take out element from a stack. Okay, so first, if the ESP equal to null means 0. So if the stack is underflows and return. If it is not underflows, we have to take the element, pop out the element, that is value equal to stack of SP display pop out element equal to value. Then decrement the stack pointer equal to stack pointer minus 1. Every time the stack pointer will decrease the value by 1 in the pop operation, and in the push operation it will increase the values by 1. So this is the program for pushing an element into the stack and pop out element from the stack. Next, students, this is the illustration of the stack operation. That is, first ASP equal to null, then push an element 5. So we insert the element 5 here, so the stack pointer will indicate the value 0. Then push an element 8, then stack pointer 1, 2, 3, 4, 5. This means the size of the stack is 5, and we cannot able to push another one element inside it. Next is pop operation. We are taking the elements one by one. The stack pointer will become 0. Next, the 0th position also the element 5 is there. If we replace the element, the stack pointer will reach us to null. This means the stack is underflows. Then type of arithmetic expressions. There are 3 types of arithmetic expressions, that is prefix, infix and postfix. Prefix means in prefix expression the operator is placed before the operands, for example plus AB into X. So first the operator, then the operands. First the operator, then the operands. It indicates the operation is performed on 2 operands placed adjacent to the operator. Infix means in this expression the operator is placed between the operands. Okay, for example A plus B, C minus D, M into N, like this. Okay. Then postfix. In postfix expression, the operator is placed after the operands. Okay. For example, AB plus XY minus MN into etc. Okay. So it indicates the operations. The operands is performed by the operator placed before. The system is also called as Polish form, and it was developed by a Polish Poland mathematician. Okay. So first, the rules to convert infix into postfix and prefix form. Um, in class 11th, there is no need to convert these numbers into postfix, infix and prefix. Just you have to learn the type of arithmetic expressions. Okay. So this we will learn in class 12th. The next one is Q. Q is a linear data structure. Q means, do you know what is called as a queue? Queue means first in, first out. So those who are standing in the first row, first of the row, they will do their work and leave the row first. Okay, that is called as a queue. Queue is a linear data structure which is usually used simply as a single dimensional array but followed with certain restrictions. Basically, it follow FIFO nature, that is first in first out. This means that the element which has entered the queue first will come out first. So in this figure, see, this is a row queue. The person who is standing in the first, he will do the work and leave the queue first. Okay, so it is a first in first operations. The figure shows the queue of people at a ticket counter. It obvious that the first standing first in the queue will get the ticket first. The person standing last get the ticket last. The queue contains two type of pointers, that is front end and rear end. Rear end means back end. The front end pointer points the data which can be deleted if required. Rear end pointer points the element which is inserted in the last. So in queue there are two operations, that is insertion operation and deletion operation. Okay, so where if you want to insert a person inside the queue, first we have to see whether the queue is overflow or not. So that is uh, rear end equal to n. So okay, we are not going to see the first n to front end to for the insertion. We have to see the rear end. If the rear end indicates the size of the queue, then we return at the queue is overflow. Okay, so deletion means delete करने के लिए we have to check whether the queue is underflow. अगर क्यू नहीं है तो we are cannot able to delete. Okay, so it is a process to delete an element from the queue. To delete an element from element of all, perform deletion and then increase the front end pointer by 1. If rear end and front end pointer points null, then there is no element available in the queue. This situation is termed as queue underflow. Okay, so this is the illustration of the queue for the insertion as well as the deletion. This is called the front end and this is called rear end. If front end and rear end indicates null, it means the queue is underflow. Here we inserted the element 5, so the front end becomes 0 and the rear end also 0. This is the front end and the rear end. Then if we insert another element, so the front end elements become 0 and the rear become 1. Here the front become 0 and the rear become 2. Here the front become 1 and the rear become 0 and 2. Okay, it's the same. Here we deleted one element from the front, so the front will become 1 and the rear will become 3. So like this the queue will do the operation for insertion and deletion. Okay, so when the front end become null and the rear end become null, so it means the queue is underflow. So this is the algorithm for insertion of a queue, and this is for deletion of a queue. So here I have given the programs for circular queue insertion and deletion operation. There is no need to study it now in class 11th. So next year we have to study about these programs and all related to queues and stack. Okay, so that's all students in data structure or data handling. So you have to learn the detail about the stack and the queue.